Hello YouTube, welcome to my channel. Today what I'm going to do is demonstrate how to extract the pure gold from scrap gold jewelry. Primarily what we're going to be doing today is the carat scrap and extracting the pure gold from the carat scrap gold jewelry. We're going to do that right now. To go through the inventory of items that I'll be working with today, I've got some test acids here, some touchstones to do some scratches of the gold material that I'll be working with. I've got some needles here with known samples of carat gold on the end of them. Got a file here. This is a silver testing solution. It's just potassium dichromate dissolved in a little dilute nitric acid. Here I have a box for the stones that I removed from the jewelry that I'll be working with today. Over here are, this is marked S. This is silver items, the catches from the silver items. I saved those. Those can be resold at about 10 times what the metal's worth. These are gold, same thing. It's just catches made out of gold that I can resell. Here I've got a bin marked 18 for 18K scrap gold, carat scrap gold. Here's another bin marked 10K. Here's another bin marked 14K. These bins already have carat scrap that I've sorted through and cleaned up and gotten ready for refining. This is a bag of gold-filled jewelry items that I'll be showing you how to test those and determine whether or not it's gold-filled. This is a bin full of gold-plated stuff, and I'll show you how to test that. I've got some basic tools here to take stuff apart. Jeweler's loupe to be able to look at the items, see what kind of markings they have on them to determine what they are. And here I have a pile of stuff that's undetermined that we picked up at flea markets, garage sales, and thrift stores. Okay, the first item that I want to look at is this watch. It's an older watch. It's a wind-up type. It's got a wind-up movement in it without a battery. And I really can't tell what it's made out of because there are no markings on it anywhere. So what I'm going to do here is I'm going to take a little screwdriver. There's a little bump right here. The other side doesn't have the bump. Take this little side that has the bump, fit my screwdriver underneath, and it pries right off. Then I grab the watch by the stem and slowly kind of just rock it back and forth until it comes out. Save those. I can use those for doing repairs of other watches. And I don't know if you can see that very well or not, but right there on the inside of the back cover it says 14K gold. So this watch, this part, the case, is going to be 14K gold. To recover the gold from this watch, what I'm going to do is just kind of bend that little ring open on both sides. Taking a pair of pliers here and just bending it open. And then the watch band will come off. I'll save that because it's probably gold-filled tops. I'll save those pieces. Now I've got the two pieces of the casing here. I just take a pair of pliers here and just kind of squeeze on it until that crystal pops out. I can save that maybe and reuse that for someone that's got a broken one that comes in. And here's our gold, 14K gold watch case ready to be refined. Stick that over here and put that right over here in the bin marked 14K. The next item I have here is a little gold bangle bracelet. It looks like it's carat gold. So what I'm going to do is rub a little bit off on this touchstone. I don't know if you can see that or not. It's rubbed off on there. And now I'm going to add a little bit of test acid to it. This is 10K test acid. Put a drop on it. And I don't know if you can see that on the camera or not, but the gold stays there. So it would be... I'd want to try to conclude that this is carat gold, that this bracelet is carat gold. But now I'm going to show you that it really isn't. Okay, it's been several minutes, and I don't know if you can see that or not, but the gold is still on the touchstone where I applied the acid. leading me to believe that this piece is going to be carat gold. But I know due to my experience that it's not. It doesn't have a marking on it. So what I'm going to do here is I'm going to file deep into this metal with a file. And then I'm going to apply a tiny drop of 14K gold test acid. And you'll see right there that we get an immediate reaction. It turns green. Nitric acid is dissolving the base metal underneath. What this is, this proves that what this is a piece of gold filled, not gold plated or not carat gold, but gold filled, which is a heavy coating of gold over a base metal. In this case, it's probably brass. And when you wipe it off, you'll be able to see the brass. The next item I have here is a silver looking ring. It's actually 14K white gold. I don't think you're going to be able to see the marking on there, but it's clearly marked 14K inside there. I'm going to show you how to test that. You test 14K white gold the exact same way that we test 14K yellow gold. White gold is an alloy of gold, silver, zinc, and just a little copper. What they'll do is reduce the amount of copper and increase the amount of white metals that they put into it to give it a gold or a white color. As you can see, it's staying in place there. This is 14K white gold. So what I'm going to do with that is go ahead and move it over here and put it into the 14K gold bin. Next item here is a gold locket, and I opened it up, and right across the bottom here it says 12K GF. Alright, the chain has a little tag on it. It says 1/20th 12K gold filled, and around the outer edge of this little catch here it also says 1/20th 12K gold filled. So these chains, both of them, are gold filled. They'll go in our gold filled bag over here. Next item I've got here is a little pin, a little stick pin. I can't quite see what it says on there from some company, but on the back right here it's got 1/10 10K. So what that means is this is a gold filled item. We'll put it in our gold filled sack over here. Next item here is a pocket watch. And the way we identify what it's made of is we open up the case back here, and right there, if this was solid 14K gold, it would say 14K gold, nothing else. But this little marking right here down, right there, it's shaped of a football. It says warranted 10 years. And what that means is this piece is made out of the backs, these little doors here, and around the case is going to be made out of gold filled material. In other words, a thick coating of a gold over a base metal, usually brass. Next item I have here is an earring. It's got a screw on back, and there's some stones in it. What I'm going to do is put the diamond tester on it here. And as you can see, the diamond tester goes up into the diamond range, which means these stones are diamond. Now I'll remove these diamonds from this earring here, because we want to save those. Those are good stones, and we can use those for other projects, or they can be resold. To do that, what I'm going to do is just go ahead and bend the metal open like that, and then the diamonds just kind of fall out there. I want to save these diamonds, so I'm going to pick each one up, put them in a sack here, and save them. This is a piece of wax I'm using here to pick them up. Got all the diamonds out of the earring there. So we'll put it over here in the 14K gold bin, ready for processing. I've got an earring here that's got like an obscure marking right there, not quite sure what it is. So I suspect this is silver. So to verify that, I'm going to rub some of the coating off in case it's silver plated. Then I'm going to add some of this solution that's potassium dichromate dissolved in a little dilute nitric acid, and instantly it forms a little red spot right there on the metal that I just scraped off, which tells me that I've got silver here. That's how you test for silver. I'll add this piece to my silver. This is all silver that I'll be using to process the karat gold. And we'll set that aside for later use, and I'll show you how to do that later on. Next piece here is a little ear ring. Right underneath, on the bottom of the post here, it's got 585 written. I don't know if you can see that or not, but 585 means 14K gold. So that means this post is 14K gold. Now, generally you can tell if the rest of the earring is made by bending it. If it bends real easy like that, like foil, then it's probably safe to conclude that this whole ring here is made out of 14K gold. I'll put that over here in the 14K gold bin. I've got everything sorted now. This is my karat gold. I've got a little 18K, some 10K, and some 14K. This is gold filled material. I'm not going to be processing that today. That's processed differently. You can see my video called Gold Filled Scrap, how to process that. This is gold plated material. We're not going to be processing that today. The way you get that off, it's got a very thin coating of gold. You put that through a sulfuric acid stripping cell. What we're primarily concerned with today is the karat scrap. That's what we're going to refine today. And we're going to use this silver and these 3 bins of karat gold to make a nice gold ingot. I've got everything sorted. 14K, 10K, and 18K. First thing I'm going to do is we're going to go ahead and get a weight on each of these and then calculate how much silver we need to add to get the karat down to 6K. I'm going to zero this out, and I'm going to add the 14K gold to this melt dish right here. Alright, got 157.5 grams, 14K, 157.5 grams. Now I'll set that aside, and in another melt dish, put it on the scale, zero it out, and I'm going to add the 10K to this melt dish. We've got 87.1 grams. 10K, 87.1 grams. And now for the 18K, I'm just going to put it into this dish. I'm going to zero it out and add the 18K scrap right there. And we got 2.8 grams of 18K. 18K, 2.8 grams. To calculate how much silver we need in the 14K sample here, we've got 157.5 grams. We multiply that by 0.583. So 157 times 0.583 equals 91.82 grams. That's how much pure gold is going to be in this 157.5 gram sample of 14K gold. To find out how much silver we need, we multiply this by 3, 91.82 times 3 equals 275.46 grams. That's how much silver we need to add to get the gold down to 25%. But first, we need to take the base metals. We need to subtract, there's base metals in this gold. So if we've got 157.5 grams of 14K, we need to remove the amount of pure gold in there, which is 91.82 grams, 65, and that will be 0.68 grams of base metals in our sample. We got 157.5. We calculated it, of that 91.82 is pure gold. To find out how much base metals we have in there, we subtract the pure gold from the 157.5 grams of 14K, which is what we did right here, and we get 165.68 grams of base metals in that gold. So we adjust the amount of silver that we need by subtracting 275.6 grams right here minus the amount of base metals that's already present, which is 65.68, and that gives us a grand total of 209.78 grams. That's how much silver we need to add to this 14K sample of 157.5 grams to get a 25% gold alloy in this melt dish. Now what I'll do is I'm going to reduce the amount of silver by 5% by multiplying this number by 0.95. So we got 209.78 times 0.95. That gives us a grand total of 199.29 grams of silver. The reason I reduced the amount of silver by this small amount here is to ensure that I don't have too much silver in the alloy. If I get too much silver in this gold alloy, then what will happen is when I go to part it out to dilute nitric acid, this will crumble and fall apart into a powder and make it difficult to get the pieces of gold out. By reducing the amount of silver, it guarantees that this gold will stay in large chunks that are easy to handle and easy to rinse the silver out of for the next step in the process. So what I'm ending up with is really about a 27% gold alloy, not 25, because I reduced the amount of silver that I'm going to add to the 14K gold. Now we're going to calculate the same exact way and find out how much silver we need to add to the 10K gold. We begin by multiplying 87.1 times 0.417, and that equals 36.32 grams of pure gold in our 10K sample here. We multiply that by 3, 36.32 times 3 to give us 75% base metals and silver and 25% gold, and we get 108.96. That's how much silver we want to add. There is base metals in with this gold, so we want to take that out and subtract it from the amount of silver that we calculated. To find out how much base metals is in here, we take the amount of pure gold that we got, 36.32, We subtract it from the amount that we started with, 87.1, and we come up with 50.78. So we get 87 grams of 10K. Subtract the amount of pure gold in it, and what we get is 50.78 grams of base metals in that sample right there. Now what we'll do is we'll subtract the amount of metal that's already in the gold from the amount that we calculated we need to get a 25% alloy, and what we come up with is 58.18 grams. That's how much silver we need. This minus this equals this. So that's how much silver we need to add to this melt dish to get a 25% gold alloy. To ensure that I don't put too much silver in and cause the gold to crumble when I add nitric acid, I'm going to multiply this by 0.95, and what we'll get is 58.18 times 0.95 equals 55.27 grams of silver. This is how much I need to add to get this to not a 25%, but actually a 27% gold alloy. 18K gold, I've got 2.8 grams. Take 2.8 times 0.75. 2.8 times 0.75 equals 2.1 grams of pure gold. Multiply that by 3. 2.1 times 3 equals 6.3 grams is what I need to add to that sample of 18K gold to get it to 25% gold. But I've got 2.8 grams of 18K, and I'm going to subtract the amount of gold minus 2.1, and that tells me I've got 0.8 grams of base metals. So I'm going to subtract that from the amount of silver I calculated. 6.3 minus 0.8 equals 5.5 grams of silver needs to go into the 18K to make it a 25% gold alloy. I now multiply that by 0.95 to reduce the amount of silver slightly, times 0.95, and I get 5.22 grams of silver needs to be added to this melt dish to compensate for the 18K that I added to the 10K melt dish. Now I'll add these two numbers together. The 10K and the 18K is in one dish. So I add 5.22 grams plus the 55.27 grams from the 10K calculation. I need a grand total of both of these of 60.49 grams. That's how much I'm going to add to this dish to get a 25% gold alloy. Actually, it'll be 27% because I reduced the amount of silver to prevent this gold from crumbling into a powder when I do the nitric acid parting off the base metals and silver with nitric. For the 14K melt dish, I need 199.29 grams of sterling silver. We'll begin by zeroing out the scale there to 0. And I've got my silver that's already cleaned and ready to be added for this process. This process is called in quarting because we're trying to end up with 1/4 gold and 3/4 base metal and silver, so that we can get the silver out with dilute nitric acid treatments, which is the next step. So there's 206 grams. It's 199.5. We'll go ahead and go with that number right there. I'm going to add this silver to this dish to make about a 27K or 27% alloy. Next, we're going to take and weigh out 60.49 grams of sterling silver to be added to our 10K and 18K gold that's in this melt dish. Begin by zeroing the container here, and I'm going to take the silver and measure out 60.49 grams. Guarantee I ain't going to have enough, so I'm going to take this sterling silver out of this set here and start adding that to it. Some of these smaller spoons, the way you can tell that's the way you tell sterling silver is it will say sterling right on the spoon. If it doesn't say sterling, chances are it's probably not sterling silver. Add a couple of those. We want 60.49 grams. We get 62. Take a little bit of the smaller pieces back out until we can get this to about 60.49 grams. We're going to go with 60. 60 grams is just fine. A little bit less silver is just fine. I'll begin by alloying the 14K gold here. I'm going to go ahead and start heating that up so we can be getting hot, melting. Now we do the same thing with the 10K gold. While doing the melt for this 10K gold, I noticed one of the items melted kind of weird. I don't think it was gold, so that means I'm going to have too much silver in this alloy. To counter that, I'm adding 5 grams of pure gold from a previous refining to make this alloy higher in gold content, because that piece of gold, that one of them chains that I put in there was not gold. So I'm adding this gold to compensate. wanted to take a moment to explain why we add silver to the gold. Everybody's wondering, why does he put silver in the gold? Why doesn't he just dissolve it in aqua regia and be done with it? Here's why. If that carat gold has a high level of silver in it, which is highly likely, if you tried to just dissolve the carat gold without adding the silver, what would happen is the hydrochloric acid in the aqua regia would form a passive layer of silver chloride over the carat gold, and the acid wouldn't be able to get to it. You'd end up with a big pile of gold encrusted with silver chloride that wouldn't dissolve. To eliminate that completely, it's called passivation. To eliminate that completely, what we do is we add silver to the carat scrap to get the gold content down around 25%, or as you can see from the calculations that I did, to about 27%. And the reason we do that is now, with the gold down to about 27% purity, I can add hot dilute nitric acid to it, and every bit, just about 100% of the gold and all the base, 100% of all the silver and all the base metals will be dissolved out with these hot dilute nitric acid treatments, leaving nearly pure gold. This is called quarting, where we get the gold content down to 1/4 gold and 3/4 silver, so that the hot dilute nitric acid can dissolve out all the silver and all the base metals. It's a necessary step that's going to save a lot of heartache later on when we go to dissolve that gold in aqua regia. Now on with the process. Here is our quarted gold that's had 925 sterling silver added to it to get the gold content down to around 27% as per the calculations that I did. What I'm going to do now is go ahead and dump the tap water out. I'm not to pour any of the gold out when I'm doing this. And that is what our quarted gold looks like. It's got a neat iridescent looking tone to it. That's how it should look. Now I'm going to get the big pieces out, just taking them out by hand and sticking them down in the beaker so I don't break the glass. Metal and glass is not a real good combination, but it's what I prefer to use because I can see what's going on inside the beaker when I do these reactions. I got the big hunks out. I'm going to pour the rest in. And I'm going to rinse them out with some distilled water. All gone. Now I'll rinse the gold off with some distilled water here. We don't want tap water containing chlorine in this next reaction, because we'll be producing silver nitrate with hot dilute nitric acid treatments. If there is chlorinated water in this gold right here, when we do that, the chlorinated water, the chlorine in the water will react with the silver nitrate and form silver chloride, and that's something we want to try to avoid in our reaction vessel here. So I'm just going to rinse it off with some distilled water a couple times. Just get all the chlorides out of this beaker so we're free of dissolved chlorides or chlorine in here. And that should do it. There's our metal. We're out at the fume hood now. I've got some previously used dilute nitric acid that came from a previous refining. what I'm going to do is I'm going to go ahead and add this to the unquarted gold. This dilute nitric acid will dissolve out all the silver and all the base metals out of this unquarted gold, leaving just the gold behind. And the reason it's so critical to use the proper amount of silver is because we want these pieces of unquarted gold in this beaker to remain intact. I do not want them deteriorating into a powder or crumbling. I want them pieces to stay whole just like they are. That's why we took such a great deal of time calculating the proper amount of silver to add to this. Now I'm going to put it on the heat back here. I'm going to begin dissolving out the base metal and silver out of this unquarted gold. Got it on medium heat. All the fumes have disappeared inside the beaker there when this first dilute nitric acid treatment. So what I'm going to do now is I'm going to pour this off into my silver jar here. Careful not to pour any of the acid out, or the gold out with it. Then I'm going to rinse it off real good with some still water. Got to use the still water here because we're working with silver nitrate. Tap water won't work. Back on the heat. Cover it with some distilled water. Now I'm going to add some more nitric acid here to get some more of the silver and base metals dissolved out of the gold. Add about, let's see here, this should be about, add about 150, maybe 200 ml of nitric here. The second dilute nitric acid treatment is complete. All the fumes are gone. I'm going to go ahead and dump this off into my silver jar here. Save it. It's going to have a lot of silver in it. Just dump this off. And then I'm going to give it a quick rinse with some distilled water. back on the heat here. Cover it with still water again. Now I'm going to add some more nitric acid, about 200 ml here. Cover it up and let it cook. Medium-high heat. This third nitric acid treatment has been on the heat now, boiling for about 3 hours. I'm going to go ahead and pour it off to my silver jar here. I'm going to rinse it out real good with some distilled water. And here you can see that the pieces of gold have retained their size. Well, not their size, they've shrunk a little, but they've retained their shape, and that's what we want. We don't want that stuff crumbling apart, forming a powder, or going into colloidal state. When it stays like this, it's much easier to handle. And that's why we calculated that amount of silver so carefully earlier in the video. Put the gold back on the heat. I'm going to cover it with some distilled water again. Go for a fourth nitric acid treatment. Add some nitric acid here. I'm going to add about 100 ml on this one. That was about 150 actually. Go ahead and cover this up. Just let it cook now. This is the fourth nitric acid boil on the gold. I'm going to get a quick temperature reading here. And we've got it boiling at 223 degrees Fahrenheit. And if you notice, there was some fumes. 23. There was some fumes in there, just a light bit of fumes on a heavy boil. So I'm just going to let this cook until there's no more fumes, and then we'll go from there. This fourth nitric acid boil has been on now for about an hour and a half, and there's no more fumes in here. And so what I'm going to do is I'm going to pour this acid off into a bottle here and save it. And you can see the pieces of gold have taken on like a tan color. And that's what we want to see. Notice how everything is held together real well. That's also what we want to see. The last thing we want to see is this crumbling apart into a powder. And it becomes very difficult to pour these solutions off. Now I'm going to rinse off the gold with some fresh distilled water here. A couple of rinses. Notice how that gold is staying together real well. That's what we want to see. Stick it back on the heat here. Going to add some distilled water. we're going to add about another 100 ml to the water and the gold here. Maybe 150. Cover this up and just let it cook a little bit longer. This is our fourth dilute nitric acid boil. It's been on here now for about an hour. I'm going to pull it off the heat, let it cool down a little bit. Alright, this is cooled off. I'm going to go ahead and pour off this hot nitric acid here into my used nitric acid container. You can see the acid is pretty clear. There's probably very little, if any, silver in the gold at this time. It's all been removed with these dilute nitric acid boils. Notice how the chunks of gold have held together nicely. This is where when we calculated how much silver to add to the gold, this is where that really pays off. When we put the right amount of silver in there, it makes this part of the refining process much easier because that gold stays together and doesn't fall apart and crumble. Add a little bit of a rinse to it. I'm going to pour that right in my used nitric jar here. I'm going to rinse it one more time. Just a little bit of rinsed water here, not much. And that gold is ready to be dissolved in aqua regia. And that will be the next step. Here's what the chunks of gold look like after they've had the silver removed with those hot dilute nitric acid treatments. After looking at it, I think I'm going to go ahead and do one more nitric acid boil just to be safe. Make sure I got all the silver out of there. I'm going to do one more nitric acid boil. Pour a little bit of distilled water, just enough to cover the gold. I'm going to add some concentrated nitric acid here, about the same amount, a 50-50 mix here. And I'm just going to put this on the heat and let it cook for about another hour. I've had the gold on a low boil here for about the last hour and a half. I believe this is the 5th dilute nitric acid treatment. As you can see, there's no fumes whatsoever inside the reaction vessel. And the gold is a nice tan color, which is what we want to see. Most importantly, though, notice that the pieces of gold have held together. They have not come apart, crumbled, or turned to powder. And that's exactly what we want to see. This is where all those calculations that we did to determine the amount of silver we needed to add, this is where that pays off, right here. Alright, I'm going to slowly pour this hot acid off into my used nitric acid jar here. Notice that acid is pretty much clear, no blue whatsoever in it. That means all the silver and all the copper has been rendered from the gold by this final dilute nitric acid treatment. This is dilute nitric acid treatment number 5 right here. Now I'll give this a quick rinse with some distilled water. And the next step is definitely this time is aqua regia. This gold has been nicely extracted. All the silver's out of it. going to go ahead and dissolve this gold now. I'd like to point out that the gold in this beaker right now, with all that nitric acid and copper removed, is nearly 99, a little over 99% pure gold. It's very close to 3/9 fine, just like it is. I'm going to go ahead and add some hydrochloric acid now, about 700 ml. I'm going to go ahead and put this gold in solution. Notice that the gold reacts immediately as soon as I put the hydrochloric acid in there. That's because we've got some residual nitric acid left in the gold from the dilute nitric acid treatments that we did previously. I'm going to go ahead and turn the heat down to medium-low. I'm going to place this on the heat now. We're going to start adding nitric acid to form aqua regia in the beaker. Before I start the nitric acid additions, I'm going to go ahead and add about 1 ml of sulfuric acid here to take care of any lead that might be in this batch. Now I'm going to start adding small doses of concentrated nitric acid. I've got a pipette here graduated up to 3 ml. 9 and 10. So that's 30 ml of concentrated nitric acid. So far we got 30 ml of nitric in there. Okay, we've got 700 ml of hydrochloric acid in the beaker there. 30 ml of nitric acid. We'll go ahead and get a quick temperature reading here. And it's currently at 106.5 degrees, pretty low temperature. Been on the heat now for about 2 hours. Quick temperature check. We're up to 157.5. I'm going to add some more nitric acid now that the reaction is slowed down here. There's 3, 6, 9 more ml of nitric acid. Got a total of 39 ml now of nitric acid. It's been about 30 minutes since we added that last 9 ml of nitric acid here. I turned the heat off and I'm going to go ahead and pull this out and let this cool off. Looks like everything's going into solution. We'll just sit there, let this sit there and cool off. Go ahead and get a quick reading thermometer wise for temperature in here. And we're at 150 degrees Fahrenheit. This is what's left in the funnel there. The filter rather. It's like some kind of, I'm not quite sure what it all is, but it isn't gold. And I've rinsed it enough now to where the droplets coming out of the bottom of the funnel are crystal clear water. we're going to add some stump out, which is sodium metabisulfite, or SMB. I'm going to add some of this chemical to the gold solution and precipitate to pure gold. Evidently, I had a little bit of excess nitric in there, as you can tell by the fumes that were created when I put the SMB in. And to remedy that, what we're going to do is just keep adding sodium metabisulfite until all adding some ice cubes to the solution to keep it cool. I'm going to keep adding some stump out until I get all the gold to come out of solution. It'll all come out eventually. Just got to keep adding the stump out. Stump out. A quick stir here. Like we got it all out of solution now. We're going to check the solution with stannous chloride testing solution on a piece of filter paper here. Make sure we got all the gold dropped out of solution. And the test is negative. And we got a slight hint of purple there. I don't know if you can see that on the camera. Still got a little bit of gold in solution, it looks like. Go ahead and add some more SMB, see if I can get everything to drop. It's a nice white head of foam, that's what I want to see. Looks like I got everything out of solution. The gold has been settling now for about an hour, and I need to dump that waste off. So I looked in my stock pot and it was full. I had to siphon out the waste out of there. And just to show you what's going on in my stock pot here, I've got a bunch of mud down in the bottom down there. This is precious metals that have cemented out on a piece of copper. Pieces of copper that I keep in here. I keep it full of copper fittings. And what happens is the precious metals, residual precious metals, will cement out onto that copper and accumulate in this stock pot. Anyway, what I'm going to do now is go ahead and dump off the waste solution out of the gold refining beaker there into the stock pot. I'm going to take the beaker with the gold in it and just pour this waste solution off into my stock pot here. Try not to get any of the gold going with it, but if a little bit does, that's okay. Lid on the stock pot, and we'll set this aside. I've got a filter set up here. Go ahead and get my beaker that's got my gold in it, and we're going to filter the gold out of the solution here. Give the gold a rinse with some hydrochloric acid. Someone asked one of the comments section, why do I do this? The reason I do this is because if there's dissolved metals in the gold, the hydrochloric acid could rinse it out, whereas water, just plain distilled water, might not be able to rinse it out. So that's why I give it a quick rinse with hydrochloric acid. It hurts nothing, and it provides a benefit. Gold has been rinsed off in the filter here. What I'm going to do is put it right back in the same beaker it came out of. The whole filter and everything. And then we're going to add about 700 ml, 600 ml. We're going to fill it to the 600 ml mark with hydrochloric acid. I'm going to cover it up, put it on the heat. Put it on medium-low heat. I'm going to add a dosage of sulfuric acid here, about 1 ml or so, half an ml. And another viewer asked why I do this. There is a benefit to this. What it'll do is if there's any lead in there, sulfuric acid will precipitate the lead sulfate, and then it can be easily 100% filtered out of the gold when we do the filtering. It doesn't hurt anything, and it provides a good benefit. So I always add just a little bit of sulfuric acid at this point. Now I'm going to add concentrated sulfuric acid to the gold and hydrochloric acid. I've got a pipette here. I'm going to add it 3 ml at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's 30 ml of concentrated nitric acid. Gold has been on the heat with the aqua regia. Now now for about 30 minutes. That filter paper in there, it will completely disintegrate, fall apart, and come out when we do the filtering. I'm going to go ahead and add some more concentrated nitric acid to it right now so we can get the rest of the gold to go into solution. Going to add some concentrated nitric acid now, 3 ml at a time. That's 1, 2, 3, 4, and 5 for a total of 15 more concentrated nitric acid. There's a total of 45 ml in there now. Just added that 15 ml of concentrated nitric. I'm going to do a quick temperature check here. And it's only 117.5 degrees in there. It's been about 45 minutes since I added that last 15 ml dose of nitric. And I want to look under here, and I can see that I still got some undissolved gold. So I'm going to add just a little bit more concentrated nitric acid. See if I can get the rest of that to go into solution. It's about 2 ml there. Still got just a little bit of the gold left down at the bottom. I'm going to go ahead and add a couple more ml of nitric acid here, 2 ml, or just under 2. Watch what happens here. Solution's hot, so it gets a nice vigorous reaction. We got a total of 30, 45, 47, 49, 50, 51, 52. I got 53 ml concentrated nitric acid. 30, 45, 47, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58. We've got 58 ml of concentrated nitric acid in here, and as you can see, everything went into solution. I'm going to bring it out here, take it off the heat, and let it cool down. Got the filter rig all set up here. I'm going to go ahead and filter the gold now so we can get ready and precipitate it. It's got a Wattman number 2 filter in it right now. Here we go. Before I went any farther, I wanted to get a temperature reading on this solution. It's got it down to 57 degrees Fahrenheit. I can tell by the way the liquid, the clarity of the liquid, that this is going to be some very, very pure gold here. Now we're going to transfer the gold bearing solution to this beaker. It's a clean beaker full of ice. Keep the temperature down. Now we're we're going to go ahead and add the SMB, sodium metabisulfite, to the gold solution. Precipitate out pure gold. Still got some yellowish orange color showing here in the solution. So I'm going to add a little bit more sodium metabisulfite. Try to get everything precipitated out properly. Give the gold a quick stir here. And then we'll let it settle. Now I'll pour off the waste solution into my stock pot located underneath the fume hood here. Now I want to get the gold into this filter here so I can put it in a melt dish and get it melted up. I've got the gold in the filter here. What I'm going to do is carefully transfer the gold out of this filter and into this melt dish without spilling it. See how we can do this. Made it. Now what we'll do is take the gold that's in the melt dish here and we'll put it down here on the table. We're going to do a melt on this now. I'm going to start the melt now. Start it off with the nat gas torch. All right, we had to break the mold to get that out of there. Some flux came over with the ball, with the pour, and glued the bar into the mold. So we had to break that mold to get it out of there. Here's our gold bar. Here's the bar. Got it sitting in some water. I'm going to add a little bit of sulfuric acid here. Just a little bit. Try to get the flux that came over with the pour off of that bar, and then we'll get it out there and get a weight on it. Here's our gold bar that we just poured. Had to break the mold to get it out of there. And now we're going to get a weight on it. See how much this thing weighs. It's 135.1 grams. Or 4.34 troy ounces. Nice. Well, that was definitely one of the more challenging videos that I've ever done. I've been up for, I can't even remember now, 48 hours or so working on this thing. I didn't go to sleep at all last night. I got our gold bar here. It's 4.34 troy ounces, 135 some grams. And that came out, the bar looks kind of, the pour wasn't that great, but you can tell it's absolutely pure gold. It's got a real nice shine to it, real pretty surface. And that will conclude this video on how to refine scrap gold jewelry. Ended up with a 4.3 troy ounce gold bar. I checked my comment section if you got any comments you want to leave about this video. It was a long one. Feel free to do so, and I try to check those every day and answer them the best that I can there. So, thanks for watching.